So for today's extra credit video, we'll be finding the particular solution of a differential equation. So the question asks for us to find the particular solution to the differential equation dy over dx equals y plus 5 times, that's quantity, times x plus 2 quantity when y equals 1 and when x equals 0. So the first thing that we do is here. So we have our equation there. That's what we're going to be integrating. So the first step, of course, is to get both variables on each, separate the variables, get both variables on each side. So you move the dx over, and then you move the y plus 5 over to the left. So you have, and then you integrate the two sides. So you have the integral of dy over y plus 5 is equivalent to the integral of dx times x plus 2 quantity, which is your second step, illustrated there. It's the second step. The next step, of course, the integral of dy over y plus 5, which is y prime over y, which is the format of the natural log, so it's the natural log of the absolute value of y plus 5, is equivalent to integrate x plus 2, x squared over 2, plus 2x plus c. The derivative of x when you integrated that becomes the constant value c, which is necessary to find a particular solution later in the first place. So that is that step there. Immediately following, you can get rid of the natural log. So it's going to be y plus 5 on the left side is equivalent to c e to the x squared over 2 plus 2x, which is this particular step there. You're just simplifying it so you can ultimately solve for c, getting rid of the natural logs and whatnot, the e-values. Then go ahead and plug in for your variables so that we can solve for that c value, which is the constant term. So of course y plus 5, if you plug in 1 for y, which was the initial conditions laid out for us, you get 1 plus 5, so it's going to be 6 is equivalent to ce. When you plug in 0 for x squared over 2 plus 2x, which is the exponent of that term, the exponent ultimately simplifies down to 0. So what ends up happening is you get 6 equals c times e to the 0th power. E to a constant is that constant. But in this particular case, that exponent is 0, which means it's just 6. So it's going to be c equals 6. So that constant is actually 6. So we get y plus 5 equals 6e to the x squared over 2 plus 2x minus 5, which was the original equation. And that step was laid out here. I'll show you. Here's the work that we did on the solving for e, which is necessary to find your particular solution. It's going to be these 3 steps here, starting here and working your way down, just plugging in the values and using your log rules to find out what c is. Then, of course, the following step is finding that particular solution, whereas you have general solutions that are left in terms of a c, which is that constant, because of course that constant could be anything when you're dealing with an integral. With the particular solution, you're given a set of initial conditions, which is usually in the form of a point, such as y equals x and x equals 1. Find the particular solution in that instance. So what you have to do, of course, is plug those conditions back in, solve for c, and then you can get your you can get your particular solution, which is what we do here in the last step, where we get y equals 6 times e to the exponent x squared over 2 plus 2x and exponent minus 5, which is written there in that last step.